Okay, guys, good morning, afternoon, whenever you're watching this. I don't know. But last lesson, yay, 10.4. Okay, it's a pretty easy lesson, but it's kind of long. There's 8, well, technically 7, 8 objectives, but I think objective 5 is left out. So I'm going to kind of go through this with you. So just 33 questions, there's 5 reading assessments, and we're talking about vectors. So a vector is kind of like an array that you might have would have learned in geometry, which I say might have, but I know you did. So there's your initial point where it starts, and it's sometimes called the tail of the vector. And then there's the terminal point where it ends. And there's always a distance. There's a distance of a vector and a direction. So this arrow tells you the direction. Okay, and so the first objective, you're going to be having to find the magnitudes. And it's kind of like absolute value. It can't be negative because it's a distance. And it's literally the distance formula you learned in geometry. So all you have to do is x2 minus x1, square it, y2 minus y1, square it. Okay, so here's an example. They give us -1 and 3 and 3 and 6. You just plug it in. This is the x's. 3 minus -1 is actually +1, and 6 minus 3 squared. So we got 3 plus 1 is 4 squared, 16. 6 minus 3 is 3 squared, 9. 16 plus 9 is 25, and it's 5. Okay, so, and it shows you like you would have started, and I drew it the wrong way, I'm pretty sure. It should have went positive because it's positive 5. The -1, 3 starts, and then 3 and 6 would be right here. So the distance between those 2 points is 5. That's what a vector is. Okay, I wrote this in here because I think it was a reading assessment, which I didn't see those notes in here. So a vector whose magnitude is 0 is called a 0 vector. All right, objective 2 is basically you're going to multiply and add and subtract vectors. Okay, so I have these 2 vectors right here, u and v. Okay, so if you're just multiplying, scalar multiplication, you're just multiplying by 1. So this, for this one, I just made up a number, k, because it looked like it was 2. If k is 2, it literally has to be parallel to it. It's going to go in the same direction. Okay, so it just doubled it, basically, doubled b. But if it's a negative, that means it's going to go in the opposite direction. So this one looked like it doubled u, but it went in the opposite direction. So you're literally just multiplying it. Those are easy, very easy. 2 vectors are parallel if there's a non-zero scalar such that u is equal to k times v. So like, because I multiplied this times 2, v and kv are parallel. Just makes sense because they have to go the same distance. I mean, not the same distance, but the same direction. That's multiplication. Vector addition. Okay, so this, it basically makes a triangle. So here is v, the same v and u as before, but this time they want us to add v and u. So it starts with u, and whenever u ends, it's kind of like I would pick this up and just move it over here. So this v and this v are parallel. It just got moved on top of u. Okay, and then the vector where you would connect those two is your u plus v. Okay, and if you're subtracting, well, that's the next page. It's got to go the other way. This is just saying that u plus v is going to be the same thing as v plus u. Because like 2 plus 3 is the same thing as 3 plus 2. Okay, and I'm going to show you how to do that in just a second. You would just be adding the x's and adding the y's to get a new point. Okay, vector subtraction, it would go the opposite way because subtracting v is the same thing as adding a negative v. And remember, if it's negative, it goes in the opposite direction. So this is v, it's still parallel to v, it's just going backwards instead of forwards. So then my u minus v is the vector that connects those two. And towards the end of the lesson, I actually have some of these examples written out, but I'm just going to go through the notes first. Okay. Vectors in terms of components. So this is when they want it in the form of A and B. So this right here is the formula you would use. I just highlighted definitions that could be reading assessments for you. So when you're flipping through these notes, that's what they use there. So you're gonna just, it's basically like the distance formula, except you're not squaring anything. Okay, you don't square it until you get to the magnitude of it. So here you just subtract the x's and subtract the y's, and you will have your A and B. So P is this and Q is this. So for the vector, I would do 9 minus 1, which is 8, and then 8 minus 2, which is 6. So my AB is 8, 6. Okay, then this means magnitude. So to find the magnitude, you're going to use the 2 points you have. 8 squared is 64, 6 squared is 36, 64 plus 36 is 100, square root of 100 is 10. So this is in components, vector in terms of components, and then this is the magnitude of it. So it's just another way to write it. Okay, a vector is in standard position if where it starts is on the origin. That's it. Come on. Okay, so I just put another one down here, but it's the same thing as up there. So to find PQ, you are doing 2 minus 1. So -4 minus 3 is -7. 7 minus a -4 is actually plus. So 7 plus 4 is 11. And then you would be doing 49 plus 121 is 170. That's not a perfect square, so you can leave it like that. Okay, then another way to write it is in terms of I and J. So a unit vector has a magnitude of 1 unit, and I have an example of that in just a minute. But A goes in front. Hang on, I gotta plug in my computer. It's about to die. I should have done that first. I'm sorry. Okay, so a unit vector whose direction is along the positive x-axis is 1, 0 for your I, and along the y-axis is 0, 1 for your J. None of that's really that important. Okay, so put a box around the important part. So your A's go with your I's, your B's go with your J's. So the first few are just writing it in terms, instead of the component vector, writing it in terms of I and J. So it gives you this component vector, which is 7, 1. And you just literally write it in this form, 7i plus 1j. If one of these was negative, then you would make these a negative. Okay, and then they have some where you have to add, subtract, multiply, and divide. You would add or subtract your A's or your I's together and only add or subtract your B's together. Okay, this is actually multiplying. So when you multiply, you have to do it times both. 8 times -3 is -24. 6 times 8 is 48. Okay, here's one where we added and subtracted so you can see what I was talking about. So first, it asked me to, it could ask you to do all of them, but I did both adding U and B and subtracting U and B. So the vector U is 2i minus 3j. The vector V is -3i plus 8j. So you're only doing your i's together and your j's together. So first we're going to add. So 2 plus -3 is -1. -3 plus 8 is 5. Then subtract 2 minus a -3 becomes a plus, and 2 plus 3 is 5. -3 minus 8 is -11. So you just do the i's with the i's, the j's with the j's. But if it's multiplication, like this one up here, you multiply I and you multiply j by the k, whatever your scalar is. Okay, so that's that one. And then these two I think are helpful. This just is showing you if you're adding or if you're multiplying, how you do it. But it's basically what I just told you. Okay, and then all your properties of vectors. These are the same things y'all have seen over and over. Commutative property, associative property, addition. So I trust y'all that y'all could read that if you need it. Okay, now objective 6 is where it gets a little bit harder, where we start adding some trig in here. Okay, it's called, I don't know why I keep doing that. Okay, direction angle of the vector. Okay, so you're still using your A, B's, I's, and J's here, but to find the angle, you're going to use tangent of B divided by A, and it's the absolute value of that, pretty much. Okay, so I wrote this in here because it was a reading assessment and I didn't see it spelled out in the notes. So for any non-zero vector, the vector V divided by the magnitude is the unit vector. So first thing you're going to have to do is find some unit vectors, which I think is actually a previous objective, but a unit vector is anytime it equals 1, and you'll see that right here. So the first type of problem you have, it says find the unit vector that has the same direction as B, and it's telling me V is just 7J. Okay, so it could have I's and J's, or it could just have 1. This just means it's 0I plus 7J. Okay, so my vector is 7J. My magnitude, remember magnitude, you just square it. So it's the square root of 7 squared, which is 49. Square root of 49 is 7. 7 divided by 7 is 1J. There's your unit vector. Here's one that has an I and a J. So first I find my magnitude, negative 6 squared is 36, plus 8 squared, 64. That gives me 100. Square root of 100 is 10. But now you got to do the V divided by the magnitude of V. So negative 6I plus 8J divided by 10. That simplifies to negative 3/5 I plus 4/5 J. And I'm pretty sure they want you to separate like that. Okay, now this other little box is a little bit harder. And so these directions was to say determine the direction and the angle for the vector. So this is my vector, 7I minus 7 square root of 3J. And this is where you use the B over A that was up there in the notes. So B is negative 7 over square root of 3. A divided is 7. So that gives me negative square root of 3, but you take the absolute value of that, and we got, square root of 3. So I know it's going to be my pi over 3, pi over 6 angle, okay? So when do I get tangent of pi over 3? Tangent is opposite over adjacent, so it has to be a pi over 3 angle. Okay, pi over 3, because they want it in terms of degrees, is the same thing as 60. Okay, but your answer is not 60 unless it's in quadrant 1. So you have to figure out what quadrant it is in. Well, X is your A here with your I, and Y is your J. So right here, my X is positive and my Y is negative. That tells me it's in quadrant 4. Okay, so basically with quadrant 4, I have to go down 60 degrees. So 360 minus 60 is 300. So my direction and angle vector is 300. Okay, and this is the formulas, so no matter what it lands in. Y'all were used to doing these before, except you use pies. Well, when you're doing degrees, pi is the same thing as 180. 2 pi is the same thing as 360. So if it's in quadrant 1, it's the angle. If it's in quadrant 2, you do 180 minus the angle. Quadrant 3, 180 plus the angle. Quadrant 4, which is what ours was, 360 minus the angle. Okay, here's another example. It kind of cut off a little bit, it looks like. But we had 10 squared root of 3I plus 10J. So this time, I wrote that. It's supposed to be B over A. No, that's right, B over A. So I get 1 over square root of 3. So that's the opposite one. It's pi over 6 angle, which is actually 30 instead of 60. I know it kind of cut off, but this is 30 right here. Okay, well, both of them are positive. X is positive, Y is positive, so that's quadrant 1. If it's in quadrant 1, it is the angle. So that's just 30 degrees right there. Sorry that it cut y'all off. Okay, another 2 important formulas right here is when they want you to give them magnitude and direction angle. So V, or whatever goes in front of your I, your A, is the magnitude times cosine of the angle they give you. And then B, which is Y, obviously goes with sine. Magnitude times the sine of the angle they give you. So here's an example down here. Okay, it says representing vector V in the form of AI plus BJ with magnitude of V and theta given. So the magnitude is 30 and the theta is 150. Okay, so I drew it out over here for you. So if it's 150, that means I'm 30 degrees from 180. 30 degrees is the same thing as pi over 6, so I need to know pi over 6 angle. Okay, but then you got to pay attention because it's in the second quadrant, which means sine is positive, but cosine is negative. So if you notice right here, the cosine is negative, the sine is positive. So 30 times cosine of 150, which is cosine of pi over 6, is square root of 3 over 2. 30 times sine of 150, which is sine of pi over 6, is 1/2. So half of 30 is 15. Here again, half of 30 is 15, but times square root of 3 and it's negative. So that's your A and your B. Now you just put those in front of your I and your J. So my answer is going to be negative 15 square root of 3I plus 15J. So I did another one and I didn't write down the steps. So before I scanned it, but I did write down the steps here. So let's see if I could, well, it might be backwards for y'all. Huh? I think I'll just write on the screen, but I think y'all could kind of understand it. Just a second, annotate, draw this. Okay, so I've got 40 and 120. Okay, so 120 is going to be right here, and 120 is 60 degrees. Sorry, this is going to be really messy. I'm doing this now. 60 degrees away from 180. So 60 degrees is the same thing as I over 3. Oh, this is terrible. I'm sorry. Okay, so we're still using this perfect triangle right here, right? So I'm drawing. I'm going to try to use my finger instead. So now I'm going to have 40, because that's the magnitude, times cosine of pi over 3, which I know in quadrant 2 is negative, plus 40 times sine of pi over 3. Okay, which quadrant 2 I know sine is going to be positive. So what is cosine of pi over 3? It's 1/2, right? But it's negative 1/2. So basically you got 40 times negative 1/2. And right here, 40 times sine of pi over 3, which is square root of 3 over 2, and it's positive. Okay, so half of 40 would be a negative, is negative 20. Again, half of 40 times square root of 3, positive 20 square root of 3. Okay. So that's how we got that one. Sorry, that's so messy, but like I said, these notes were meant for me, so it was just if y'all needed another example in class, I'll write another example down. Okay, and last one, objective 8, you just have one of these. Okay, is a word problem. Okay, so right here, this is an output and releases a baseball with the speed. This is your magnitude right here. So my magnitude is 80 and an angle of 30 degrees. So that's my theta, which 30 is the same thing as pi over 6. So I drew my pi over 6 angle. Okay, so same thing you just did, just with words this time. And there's just one, so it could be this one on your homework, or it could be another one. They have some to pull from. So it's 80 times cosine of 30 and 80 times sine of 30. 30 is in quadrant 1, so everything's positive. 80 cosine of 30 is square root of 3 over 2. 80 times sine of 30 is 1/2. Half of 80 is 40. So your A is 40 square root of 3. B is 40. 40 square root of 3I plus 40. And that's it. This is your last homework. It's not that bad. There's just a lot of notes that go with it. But good luck. I'm so excited for y'all. And really, I think on your final, there's like one question from this homework. So I wouldn't like focus on it too much. Sometimes in the past, they didn't even get a question from 10.4. So I would just do the homework and be done with it. No quiz to even go with it. So good luck. Let me know if y'all have any questions, and y'all have a good day.